All right, so we're going to look at some examples of how you solve trigonometric equations. So we're going to use a lot of the same strategies that we would use to solve other equations, algebraic type equations, only we're going to have trig functions involved. And so then, yeah, we've got to solve for that particular trig function. So I'll show you what I mean here in just a second. The directions typically will give us a hint as to how we're going to state our answers. So the directions will typically say something like solve over the interval from 0 degrees to 360, or it'll say solve over the interval from 0 to 2 pi. So if it's saying 0 to 360, then obviously you want to give your answer in degrees. If it's saying 0 to 2 pi, then you want to give your answer in radians. I would suggest practicing a little of both for the problems that you are practicing. Okay? Along the way, if you need to kind of stop and think about what we are doing, you know me, I tend to get excited and I start working quickly. So if you need to pause and rewind, you can do that. Stop and think about what the answer is before I tell the answer, that type of thing. All right? So one hint that I will give you, there are kind of some tricks on some of these problems, so that's part of the reason why I'm going to show you some examples. But the other general suggestion that I would make is if at any time you're looking at these problems and you're just getting confused because of these words in this problem and you're having a hard time solving, then my suggestion is rewrite it with just the algebra and then solve it that way, and then go back and put the trig function back in. So I'm going to show you that example kind of for this first one. So instead of thinking of this as this 5 cosine x equals 3 cosine x plus root 3, let's rewrite this. Let's get rid of the cosine in there, and let's just write this as 5x equals 3x plus the square root of 3. Now we can focus our attention on just solving that. And if you think about what we would do, we're trying to solve for x, so we're going to subtract the 3x from both sides, right? And then we are going to have to, in order to get x by itself, we're going to divide by that 2. So we get cosine of x is equal to the square root of 3 over 2. So now we've just got to kind of add one more step kind of to this, and instead, and I'm totally fine with you doing this algebraic work and then going back and saying, okay, now what this really means is that the cosine of x is equal to the square root of 3 over 2. And then we're going to unit circle. And we're looking for where are the x values, right? Because cosine is our x, sine is our y values. So where are the x values on the unit circle equal to the square root of 3 over 2? And that is at pi over 6 and at 11 pi over 6, better known as 30 degrees and 330 degrees. Okay. If you notice, I'm kind of giving you some hints about how we are going to be solving some of these. I'm going to keep this with the tan in there and not rewrite this using just the algebra. I think you can see it a little bit clearer on this one, what we're going to do. So we have this 3 tan squared x equals 1, and then we get tan squared x equals 1/3, and then we're taking the square root of both sides in order to solve. And remember, when we do that, if we're taking the square root of both sides, we have to consider the positive and the negative. So the square root of 1 just gives us 1, and then we get the square root of 3. We can rationalize that, and we need to in terms of how we write our answer, but actually looking for our tangent value on the unit circle, it might be helpful to look at it in this format because it shows us the numerator of the y over the numerator of the x is that 1 over root 3. Now that rationalizes to the square root of 3 over 3. But on unit circle, you can be looking for that tangent of numerator of the y is 1, numerator of the x is root 3. And that is at all of our 30-degree reference angles. So I'm going to write that as pi over 6 and 5 pi over 6, 7 pi over 6, and then 11 pi over 6. Okay. Onward, if you notice these next couple, we're going to factor. And if you notice also, it's telling us that we are solving over the interval from 0 to 2 pi. So we know we want to give our answers in radians. So if we're going to factor, we need one side set equal to 0. So I'm going to move this sine x, that square root of 3 sine x, over to the left-hand side. So we get minus the square root of 3 sine x, and then that's equal to 0. And then if you notice, we have a common factor of sine x that we're going to factor out. And when we do that, we get this sine of x times 2 cosine of x minus the square root of 3, and that's equal to 0. So then we're going to set each of those factors equal to 0 and solve. So we get sine of x is equal to 0, and then we get this 2 cosine x minus root 3 equal to 0. We've got to solve for that still a little bit, so we're going to add the square root, divide by 2. So we get that the cosine of x is equal to the square root of 3 over 2. So now we want to go back. We want to look at unit circle. We're trying to figure out where the sine of x, that means the y values, are equal to 0. And so that means that we are going to be at 0 or 0 pi, and also at pi. And then we're also looking for where the cosine value is the square root of 3 over 2. And that is at pi over 6 and 11 pi over 6. We're getting a whole lot of answers that have this pi over 6 business, the 30-degree reference angles. And so just so that you do see that you do get other answers other than that, I am going to change this problem. So I want you to notice, instead of the sine squared, I'm going to use, and the sine, I'm going to change this to cosine. So please make that change. I will tell you, for this particular problem, I think it is easier if we look first at this as if it is just a basic algebraic problem to factor, and then we will go back and put the cosine back in there. So we need numbers up front that multiply to give us this 2x squared. So I'm going to use 2x and 1x. And in the back here, I need numbers that multiply to give me 1. So I know that's going to be 1. And then I need a positive 1x here in the middle. And so for that to work, I need this to be positive and I need that to be negative. So go back and think about that. Pause if you need to take a look at that. Now I want to go back and put my cosines in there as well. Or actually, we don't have to. Let's go ahead. Let's just keep this as 2x minus 1 equals 0 and x plus 1 equals 0. So we get x equals negative 1. Here we get x equals 1/2. Now let's go ahead and add our cosine in there. So the cosine of x is 1/2. The cosine of x is negative 1. So looking on our unit circle for where the cosine of x is equal to 1/2, we find that we get x is equal to pi over 3 and 5 pi over 3. And cosine of x is equal to negative 1 in only one location, and that's at pi. All right, onward. We're going to look at a few more examples, just a couple more, 3 more, I guess. The 2 on the next page kind of have a little bit of a trick to them. And then the one on the page 27 that we will look at is a bit more involved. All right, once again, if you notice, it's saying from 0 to 2 pi on both of these, so we are going to use radians. So on this first one, if you notice, this first example, if you notice what the problem has in it, I'm seeing sine and sine, but then over here I'm seeing this cosine. Now some of them are squared, some of them are not. And so because we have this sine squared x and then a sine x term, I'm going to rewrite my cosine squared. You guys thought we were done with this, but we're not. This cosine squared, so that I have all of the same trig function, I want to rewrite that as 1 minus sine squared x. Now I'll keep this other side the same. So I have sine squared x minus sine x plus 1. And then that's equal to my 1 minus sine squared x. So I'm going to want to try to factor this because it's quadratic. So I've got to move everything over to the other side. So I'm going to subtract that 1. I'm going to add this sine squared x. So actually I have this now when we combine our like terms. So we get 2 sine squared x minus sine x, and that's equal to 0. So we are going to look into factoring out a common factor. So I'm going to kind of highlight there so that you can see we've got a common factor of sine x. And then I'm going to, what's left on the inside is going to be a 2 sine x minus 1. And now I'm going to set each of these factors equal to 0, and I am going to solve. So sine of x equals 0. 2 sine of x minus 1 equals 0. So sine of x equals a half, and sine of x equals 0. So sine of x, that's the y values, equal to 0. That's going to be at 0 and at pi. And sine of x is a half. That is at, whoops, I'm sorry, pi over 6 and at 5 pi over 6. All right, so you thought you were done with identities, but you weren't because you had to do this rewrite, didn't you? All right, so keep that in mind. That's kind of an extra added little trick to kind of keep in mind. And let's look at this next one. So on this one, the thing to notice is that we have two different trig functions. We have sine of x and cosine of x. Neither of them are squared though. We could probably do something if they were squared. So actually that's kind of the trick on this one, is to realize that we are going to square both sides. That's legal as long as we square both sides. That means we are keeping the value the same. Okay, so I'm going to write this off to the side over here because it's easy to get confused when we are squaring this. So we need to write those two terms out, and we are going to FOIL. So when we do first, we get sine squared x. When we do outside, take a look. For outside, we get minus sine x cosine x. For multiplying the inside, we also get a minus sine x cosine x. And then lastly, when we multiply the last terms, we get plus cosine squared x. So that was my work kind of off to the side, but now let's write that over here. So I have sine squared x minus 2 times sine x cosine x plus cosine squared x. And then I'm hoping you guys see this. Think about what that is equal to. So that gives us a 1 minus 2 sine x cosine x, and that's still equal to 1. But when we try to set this equal to 0, so that we can factor, because it was quadratic, actually in this case we've got our factors, we end up with negative 2 times sine x times the cosine of x is equal to 0. And so now from there we've got to solve. We've got two terms, the sine x and the cosine x, that might be making this equal to 0. It's definitely not the negative 2 that's making it equal to 0. So we have our two factors, the sine x and the cosine x. So we're going to set sine of x equal to 0 and solve, we're going to set cosine of x equal to 0 and solve. And we know that when sine of x is equal to 0, that's at 0 and at pi. And cosine of x is equal to 0, that is at pi over 2 and at 3 pi over 2. And we are done with that one. All right, we've got one last example we're going to look at, and it is at the bottom of page 27. And the reason why we're going to focus on this one is because of how we actually have to solve this and what we're going to do on this. So it's quadratic, so we should be looking at how we can factor this, but as it turns out, you cannot factor it. And so we have got to do quadratic formula. So we're going to say that x is equal to the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And we've got to clean this up. So we get negative 4 plus or minus the square root of 32 all over 8. And so we can clean up that square root. We can simplify that. That's 16 times 2. So we get 4 root 2 all over 8. And we've got Mickey Mouse ears. Right? So then that means this simplifies into negative 1 plus or minus 1 times the square root of 2 all over 2. And now we need to go back and put our cosine back in there. So this would be the cosine of x is equal to negative 1 minus the square root of 2 all over 2. And then the cosine of x is negative 1 plus the square root of 2 all over 2. So this is a problem you would use your graphing calculator for, and you would actually plug in. So you would plug in negative 1 minus root 2, find that answer, divide by 2. You get a decimal, and then you're going to do inverse cosine in order to find what your x value is equal to. And then similarly, again, you would do negative 1 plus square root of 2, divide by 2, get that decimal, inverse cosine to find your answer there. I'm not going to go through that process. You can check those answers if you would like, but I'm sharing this example. This would be more like a bonus type question on the quiz, but I just wanted you to be aware that potentially you could have to do quadratic formula. All right, so your homework, your class homework for this is to finish up the examples that we did not do on page 26 and on page 27.